Hello and welcome to Week 4. This week covers Part 2 of Chapter 3 Remote Instructor Training Overview. Chapter 3 Sections and Objectives. You should continue reading Chapter 3, review this video, complete the rest of the Chapter 3 required labs and lab reflections, and take the Chapter 3 exam before continuing on to the next chapter. Chapter 3 Lab Overview. Lab 3.2.5.11, Blinking a LED using Raspberry Pi. Time to complete is approximately 30 minutes. Difficulty level easy. In this lab you will use Blockly to flash a LED. Setup is similar to the Arduino lab except the pin numbers are different. The Raspberry Pi uses the GPIO, General Purpose Input/Output, configuration. A 40-pin GPIO header is found on all current Raspberry Pi boards. Any of the GPIO pins can be designated in software as an input or output pin and used for a wide range of purposes. The GPIO.BCM option means that you are referring to the pins by the Broadcom SoC channel number. Note the BCM pin number and the actual pin number are not the same. Double-check the pin-out guide for the correct pin number. Pin number 1 is located at the back of the board, opposite the USB ports and to the left. This is the completed version of the 3.2.5.11 lab. Open the Raspberry Pi Jupyter Notebooks application from Chrome by either clicking on Connect from the PL app or by typing https:// and the Pi's IP address into the browser. The password was set during the initial setup in PL app. Double-click on My Files and choose New, Python 3, then click on the Blockly icon. Rename the program and save. Note, it's a good idea as with any program to save often. Follow the instructions and complete the Blockly program. When you click Run, the LED should begin blinking. Troubleshooting steps to keep in mind: program coded incorrectly, bad or backward LED, or wiring issues will keep the lab from working correctly. To extend this lab, challenge your students to write Morse code to blink SOS. Lab 3.2.6.4, Interfacing Arduino code and Python code. Time to complete is approximately 45 minutes. Difficulty level intermediate. In this lab you will interconnect the Arduino and Raspberry Pi, then use the Raspberry Pi and PL app to read data from the Arduino. You will set up the Arduino circuit as shown. Plug the Arduino into your computer and then use the Arduino IDE to code and upload the program. You can use the Arduino serial monitor to check the circuit is working properly. As you cover and uncover the photoresistor you should see the values change. Troubleshoot as needed. Once the Arduino is working properly, then you will interconnect the Arduino and Raspberry Pi with the Arduino's USB cable. Plug the Arduino's USB cable directly into any of the Raspberry Pi's USB ports. Access Jupyter Notebooks and create a new Python 3 project. Name and save the project. Type the code shown in the lab. Note, put each code block in its own cell. You will need a total of 5 cells for the basic project. There are 3 ways to monitor the Arduino values. I am only showing the first one. You can optionally have your student use the one that best suits your needs. This is the completed version of the 3.2.6.4 lab. When you click Run, you will see the photo sensor values start scrolling below the code block. Run the ser.close cell to stop reading changes. Save, close, and halt when finished. Troubleshooting steps to keep in mind: Arduino or Python program coded incorrectly, circuit errors, or serial connection issues will keep the lab from working correctly. 3.2.6.5, LED line and graphs. Time to complete is approximately 90 minutes. Difficulty level intermediate. In the lab you will build 5 LED circuits on the Raspberry Pi and a potentiometer circuit on the Arduino as shown in the lab. Then interconnect the Arduino and Raspberry Pi and flash the Arduino with Fermata. This will allow you to control and read the Arduino's output values using the Raspberry Pi, which will control the LED circuits. Finally, you will create a graph to display the Arduino's values. This is the completed version of the 3.2.6.5 lab. As before, you will need to find out the value of the USB connection. Use that value to flash the Arduino with Fermata. An output of 0 indicates the Fermata was successful. When the Blockly code is run, you will see a graph appear below the cell indicating the position of the potentiometer. This will also change the number of LEDs illuminated. Troubleshooting steps to keep in mind: Arduino not flashed correctly, Python program coded incorrectly, circuit errors, or serial connection issues will keep the lab from working correctly. Lab 3.2.6.6. Control LEDs from the PL app dashboard. Time to complete is approximately 45 minutes. Difficulty level intermediate. In this lab you will build 2 LED circuits on the Arduino, interconnect the Arduino and Raspberry Pi, and use the Raspberry Pi and PL app to control the Arduino's LEDs. This is the completed version of the 3.2.6.6 lab. As before, you will need to find out the value of the USB connection after you have made the Arduino Raspberry Pi serial connection. This next block of code demonstrates how interactive functions are created using Interact from Pi widgets. In a new cell you will import Pi Fermata and define the pins used to control the LEDs. The final cell will define the functions of the interactive checkbox and slider. Pin 9 will turn on and off with the checkbox and pin 11 will dim with the slider. Troubleshooting steps to keep in mind: Python program coded incorrectly, circuit errors, or serial connection issues will keep the lab from working correctly. To extend this lab, challenge your students to change the code so you can turn on, off and dim the same LED. Packet Tracer Lab 3.3.1.4, SBC Actuate. Time to complete is approximately 30 minutes. Difficulty level intermediate. In this packet tracer activity you will use a Raspberry Pi or single board computer, SBC, to control the coffee maker and countertop lamp based on the input of the motion sensor. This lab could be done on real equipment if you have a motion sensor and something to control. I have given you some ideas of real components to use. You will complete these labs and reflections during week 4 of your training. If you have any questions, please feel free to contact me.